Leshire math here. Let's proceed with the question number 8. Question number 8 test on mixed concept ranging from getting the equation of a circle, determining the stationary points, and also it tests on area under the curve. Now we can go through the question part. The first part of this question says Figure 3 shows a sketch of a circle C and a parabola S. The circle C has equations x squared plus y squared minus 8x plus 12y plus 27 is equals to 0. Part A, find Roman 1 the coordinates of the center of C. Roman 2 the radius of C. Now with this, we know that for us to find the coordinates of the center of a circle and also its radius, we can either use the concept of completing square method, or we can use the formula. And in this case, I will use the formula in working out part A. So we are starting with the part A, of course, Roman 1. Now, by formula, we know that the coordinates of the center of a circle, let's say O, is given as negative h over 2, negative k over 2, where h and k are the coefficient of x and y respectively. So if we consider the equation of the circle you've been given as x squared plus y squared minus 8x plus 12y plus 27 is equals to 0. So in this case, it means that in our case, the value of h is simply negative 8, and the value of k is simply 12. We pick the coefficient of x and y with the corresponding sign. Now, substituting the values of h and k in the formula, we'll have the coordinates as, we'll have 0, not 0 but O, into negative 8. Of course, we have a negative in h, so this one will be positive 8 over 2, comma, negative 12 over 2. And simplifying this, 8 divided by 2 gives you 4. So it means the coordinates of the center here, center will be coordinates, simplifying this is 4, negative 6. We can also proceed with Roman 2. Roman 2, you are required to get the radius of the circle. Still, we can use the formula. We can say that radius is equals to the square root of negative h over 2, we square this, plus negative k over 2, we square this, then minus c. And in this case, c is just the same as the constant in the equation of the circle. And going back by what we have, the constant in this case is going to be 27. So this one is the value of c. So when we substitute everything that we have, then it means the radius will be given as the square root of course, negative h over 2 already we've determined as 4. We square this, plus negative k over 2 already we have as negative 6. We also square this. then the constant c is the same as 27, so this one will be minus 27. Simplifying further, we know that 4 squared is the same as 16, negative 6 squared is the same as 36, then this one minus 27, we get the square root. So by using our calculator, we can have this one as 16 goes plus 36, then minus 27. This one gives you 25, and the square root of the answer gives you 5. So this one is just the same as root of 25, which is equivalent to 5. So the radius in this case is simply 5 units. We can also proceed to part B of this question, part B. Going back to what we have in part B says the parabola S has equation y is equals to a x squared minus 3 over 2x minus 3 intersect C on the y-axis at the point A, coordinates 0, negative 3, intersect C again at the point B, where AB is a diameter of C, given that B is the minimum, given that B is simply the minimum. So there's some information we are given here. C intersect the y-axis at the point A, 0, 3, and also intersect the point B, where AB is given as the diameter. And also you're told that given that B itself is the minimum point of S. Remember, S is the parabola. So the first bit show that A is equals to 3 over 32. Now, the first step in this case, I will want us to get the coordinates of B, which is the other end point of the diameter. Now, what are we supposed to do here? What are we supposed to do? One, we are given point A having coordinates 0, negative 3, and already we have the center having coordinates 4, negative 6. Now, by a sketch, just a sketch, a simple sketch, if at all this one is the diameter of the circle, and this is point A given by the coordinates 0, negative 3, this is point B. We have x, y, and the center is somewhere here. The center is given as 4, negative 6. We can use the concept of midpoint for us to get the coordinates of point B. So if we start with the x coordinate, we know that by midpoint it is x coordinates of the endpoints divided by 2 to give you the x coordinate of the center, and y coordinates of the endpoints of the diameter divided by 2 to give you the y coordinate of the center. So here we'll say, based on what we have, x of B, we add to 0, everything divided by 2, this one will give you the x coordinate of the center, which is 4. So when we simplify in this case, this implies that x coordinate of point B is simply equals to 8. 2 times 8, 2 times 4. Then we can also get the y coordinate of B, y coordinate of B plus the y coordinate of A plus the y coordinate of A, which is negative 3. Everything divided by 2, this one should give you negative 6. Cross multiplying this, we'll have y coordinate of B minus 3. This one should be equivalent to 6 times negative 6. 2 times negative 6 is simply negative 12. This one will be YB will be equivalent to negative 12 plus 3, which is simply equivalent to negative 9. So this means that the coordinates of point B is simply 8 and negative 9. So this is X and Y coordinates of point B. Number 2, based on what we have back to the question says that the parabola has equation y equals to ax squared minus 3 over 2x minus 3, and also it denotes that given that B is the minimum point of S. So the equation of the parabola is here. The equation of the parabola is here. You are given y equals to ax squared plus 3 over 2 x minus 3. Now we know that at minimum point, because B is of course the minimum point, we know that at minimum point the gradient function is equivalent to 0. So this means dy dx is equivalent to 0. So what do we need to do? One, we need to find the derivative of the parabola. So this implies that we can have this space. This implies that differentiating this, will say that dy dx will be equals to, this one will be 2ax minus 3 over 2. Then we can set this to 0. We can set the gradient function to 0. So we'll say that 2ax minus 3 over 2 is equivalent to 0. But remember, we are told that point B is the minimum point. So therefore, at point B, the value of x is simply equals to 8. So x here is 8. So what do we need to do? We can substitute back. So we'll have 2 2a into 8 is minus 3 over 2 equals to 0. Simplifying this one is the same as 16a equals to 3 over 2. You can divide through by 16, divide through by 16. So this means that a is simply equals to 3 over 2 divided by 16, 3 over 2 divided by 16. So a gives you 3 over 32, hence shown. So we've shown that a is actually 3 over 32. So that marks the end of part B. Now we can consider part C. We can consider part C of the same question. Part C of the same question. And going back to what we are given up here, they're saying that the finite region R is bounded by S and C and is shown shaded in figure 3. Use algebraic integration to find the exact area of R. So based on this, based on the diagram, we are required to find the shaded area R. But if you look at the shaded area R, first we have a semicircle. we have a semicircle that is above line AB, and number 2, we have a region between line AB and parabola S. Actually, that region is below the line AB. So majorly what we can do in this case, we can get the area of the semicircle ACB, area of the semicircle. Then we find by integration the area bounded by the line AB and the parabola S. So the first step here, what I want us to first determine, I want us to determine the equation of line AB. The equation of line AB, because it will assist us to find the specific area under consideration. Going by this, for us to get the equation of line AB, first we'll start with the gradient. Gradient over line AB. Gradient is given as change in change in y over change in x. Based on the coordinates we have, then this one will be equals to -9 minus 3, everything over 8 minus 0. And when you simplify, this one is just the same as -6 over 8, and this equals to -3 over 4. So already we have the gradient. Then for us to get the equation of line AB, equation of line AB will be given by, generally all equations takes the form y equals to mx plus c. But you see already line AB cuts the y-axis at point 0, -3. So this means that already the y-intercept, that is c, is the same as -3. And the gradient already we have is -3 over 4. So when we substitute, then it means the equation here becomes y equals to -3 over 4 x minus 3. Number two, for us to get the area of region R, what are we supposed to do? 1, we'll get the area of semicircle above line AB. We've seen that in the diagram given, that figure 3. And remember, area of a semicircle is normally given as a half pi r squared. And in this case already we know that the radius of that circle is given as 5 units. So when we substitute what we have here, then it means the area becomes a half pi multiplied by 5 square. And this one is equivalent to 25 over 2 pi as the area of the semicircle. Number 2, we also need to get the area. Number 2, we also need to get the area of the region between line AB and parabola S, between line AB and parabola S, and of course that area is simply below line AB. The area is simply below line AB. So what are we supposed to do in this case? Let me take you back a bit. What you are required to get here, or what we are interested in getting here, is the area. No. What we can get the area of this region, this one, this region shaded in yellow. So how do we get the area of this region? How do we get the area of this region? This is what we are going to do. This is what we are going to do. We'll integrate line AB, then we subtract, also we'll integrate parabola S. Of course, if we go by this, then it means check. 1, the equation of the parabola already, if we replace the value of a with 3 over 32, will be 3 over 32 x squared minus 3 over 2 x minus 3. So considering what we've said, integrating, finding the integral of line AB, and also we subtract the integral of the parabola. This one will be area, will be the integral from 0 to 8 of equation of line AB is negative 3 over 4 x minus 3. We subtract equation of the parabola, which is 3 over 32 x squared minus 3 over 2 x minus 3. And of course, simplifying these two equations, this one will have first negative 3 over 4 plus 3 over 2, which possibly will give you 3 over 4x, negative 3 over 4x, plus these two, we can combine them, this one and this, negative 3 over 4 and negative 3 over 4x plus 3 over 2x. So these two will give us, so what we'll have here will be still area as the integral from 0 to 8 over negative 3 over 32 x squared, then plus 3 over 4 x, of course with respect to x. Now integrating this, what we'll have, if we integrate this, what we are going to have here, we will have of course what we are supposed to do, we increase the power by 1, then divide by the new power. So that means what we'll have here will be negative x squared, x cubed over 32 plus, integrating this, you'll have 3 over 8 x squared from 0 to 8. We can substitute the value of x with 8, and we subtract when x is equals to 0. So this means that what we'll have here, substituting back, we'll have negative into 8 power 3 over 32 plus 3 over 8 into 8 square. Of course, this one we subtract 0. So we can solve this further using our calculator. We'll have negative 8 power 3 everything over 32. Then we'll add 3 over 8 8 square. This is supposed to give you simply 8 units. Of course, 8 square units. 8 square units. Now, what is the total area? So here we can say that total area of R will be given as, initially we got the area of the semicircle to be 25 over 2 pi, and we've gotten the area between the region, or the area between line AB and parabola S to be equals to 8. So this one becomes the total area of region marked R, and this marks the end of question number 8.